In this problem, we're asked to find the instantaneous rate of change of f of x equals 3x minus 8 when x equals 2 by using the definition of the derivative. And the note is that you probably know the answer already. If you look at the function, you can see that it's a linear function, which means that its slope would actually be 3. But we're going to go ahead and verify it by trying to use the definition of a derivative. So remember, the definition of a derivative says that you want to figure out what the slope is tending towards as the distance between the 2 points that we're comparing for the rate of change get closer and closer and closer together. So this is what it looks like. So it just looks like the typical rate of change equation. And we want to say, okay, well, as these points get closer and closer and closer together, so let's just say you had a function that looked like this, and as you moved this point closer to the point of interest, let's say that's the point of interest, and you started to find these rates of change, and you started to find these rates of change, and you found them, you would get a more accurate estimate of what's actually happening, the snapshot view of this point right here. So what we're going to do is we're going to figure out what the derivative is when x is equal to 2. So I am just going to go ahead and write out f of 2 plus h minus f of 2 divided by 2 plus h minus 2. So we need two things. We need to find f of 2 plus h, and we need to find f of 2. So I always like to start with the easier one. That just says plug in 2 for x in the equation. That's going to be 3 times 2 minus 8, which is equal to 6 minus 8, which is negative 2. Okay, so the output, one of the output values is negative 2. The second one, f of 2 plus h, is symbolic because we don't actually know how far away this next point is from 2. We just know that it's h units away. So symbolically, this means anywhere I see an x, I'm going to plug in a 2 plus h. And so I have 3 times x, so I'm replacing x with 2 plus h, minus 8. And all I can do now is, because I have a symbol in here, I can only simplify this. Can't actually get it down to a single number. But I distribute my 3. 3 times 2 is 6. 3 times h is 3h. And then I have minus 8 here on the end, which simplifies to 6 minus 8 is negative 2. And then I have a 3h left over, which cannot be combined. Okay, so I have 3h minus 2. And now what I'm going to do is I'm going to plug things back into here. Now, we are going to apply this limit. I'm just going to draw an arrow so I don't have to keep rewriting it. So this guy is going to be equal to f of 2 plus h, which is equal to 3h minus 2, minus f of 2, which f of 2 itself is negative 2. So be careful here. We got to put minus and then parenthesis negative 2. Divided by, well, what do we get when we take 2 plus h minus 2? These guys will cancel, and we'll just be left with an h down there. Okay, so what happens here? Well, we get 3h minus 2 plus 2, and the minus 2 and the plus 2 are going to cancel out, so we're just going to be left with 3h over h, which simplifies down to, if you cancel out an h from the top and the bottom, you just end up with 3. Okay, well, now this is the point where I would go ahead and plug in my 0 for h if I had one left over, since I no longer have one in the denominator. However, notice that, well, what do you get if you substitute in 0 for h of the function, the constant function 3? Well, you get 3. Why is that? Because if you think about 3 as being 3 plus 0h, well, if I plug in 0 for h, it's not really going to change the fact that this is a 3. But that makes sense because we expect the rate of change to always be 3 no matter where we're looking. So we have just confirmed that we do in fact get 3, which comes out of this limit function.